Good day, folks. Welcome to our session today. We're glad you were able to join our session today on Azure ML Developer Experience. My name is Mir Alam. I'm a principal customer engineer in our Fast Tech for Azure team. I help our customers onboarding solutions implemented in services around data and AI. With me, I have Varma. Varma is a colleague of mine who is specializing in the same areas. Varma, would you like to introduce yourself?
Yes, thanks, Mir. Hello, everyone. Thanks for taking the time to join us today. I'm Varma. I work in the same team as Mir and Jamil. I will specifically focus on helping customers build solutions on Azure with our machine learning and AI services. And as Mir mentioned, we also have Jamil today, who is helping us in the backend, answering your queries. So please feel free to say hi to him in the chat and also drop any questions that you might have. Thanks, Mir.
Thank you, Varma. And as we go along, I would like to share the fact that we have a great collection created for you as we walk through with the Azure ML service, the different tools that are going to be leveraging to train our model, and to register a model, and all other work streams that you need to perform for an end-to-end solution for Azure ML models. Feel free to walk through the collections as we discuss, and obviously feel free to ask the questions, um, so that we can ask the questions as you go along. We have a great show today for you on Azure ML Developer Experience. Um, Consider that you have a ML model created with open source tools in your on-prem environment, and you are now ready to bring that model into Azure ML, into Azure, and you want to leverage the Azure ML service. Uh, what we'll do today is we'll walk you through how you get started. We'll talk about the Azure ML service. We'll talk about the Azure ML Studio or Machine Learning Studio. We'll walk you through the entire life cycle of how you get the data, train the model, register the model, and deploy the model into an endpoint. And once you have it deployed, then you definitely want to perform the inferencing asked against that endpoint. So our goal is to make you comfortable at the end of the session. Our goal would be that you are comfortable bringing your ML models and essentially deploy the models in a production scenarios. Um, so, Varma, would you please walk us through as a precursor on the Azure ML service and the big components that we need to be familiar with?
Absolutely. So as Mir was mentioning, we have a lot of content to walk you through today. But just to set the baseline for everyone, for someone who is not familiar with Azure Machine Learning services, I would like to briefly talk about what the service is about, what kind of functionalities does it offer, how do you create it, and how do you interact with it. So at a high level, for any machine learning project workflow, if you look at the life cycle diagram here, that is what the high level steps include. Whether you're
Varma,
actually,
we need to have your screen shared. Todd, could you please share Varma's screen?
I think it
Thank
is
you.
up now.
Yes.
Great. So as I was referring to earlier, this is the diagram which represents the high level project life cycle of any machine learning project. Now you would obviously define your machine learning task. The most important aspects are acquiring the data that is needed for you to help define the task and also be able to solve the task at hand. It can be a business problem like credit card fraud, or predicting house prices, or any simple use case. And then of course you will go to the next stage of the life cycle, which is training and validating the model. Here is where you would experiment with different algorithms based on the task, whether it's regression or classification or forecasting, and also experiment with different set of hyperparameters to get the right model that's going to give you the great outputs. Now, once you have that, you're going to deploy the model depending on how you want the model to be interacting with your users, or your users interacting with your model, whether it's going to be real time or batch predictions based on the business case. And then of course, All these steps are not steps that are actually performed at once. These are repetitive steps, which means you are going to iterate on these steps again and again, depending on how frequently your data is changing, depending on what new algorithms you would actually like to train and retrain your model, as well as change your deployment scenarios. Now, machine learning services is a platform on Azure that will enable you to perform these steps with utmost effectiveness, as well as to increase your productivity while you're doing that. So let's take a quick look at Azure Machine Learning Services and the different components and dependencies that it has. So Azure Machine Learning Service at the center is a workspace that is enabling you to perform operations like training experimentation, model deployment, compute deployment, and all the other capabilities. To be able to provide these services, Azure Machine Learning Services depends on some of the base functionalities on Azure. For example, to be able to train and deploy your models, of course, we do need compute, and those compute capabilities come from our infrastructure as a service offering. And we do have two different types of compute services, like the compute instances and the compute clusters. Now, these services are essentially a single virtual machine compute instances, as well as a cluster of machines for you to be able to train some complex models or perform distributed training. And also Azure Machine Learning Services primarily depends on Azure storage for storing all the log files and some of the data and setup scripts and all of that that help the workspace to run, as well as container registry. And so because once you have your training files, the unit tests or the model files and all of that, all of them are actually packaged up into Docker containers, and Azure Container Registry is where all those container images are held. And we also have Azure Key Vault integration, given the importance of having to protect your usernames and passwords or connection strings to your SQL data stores or blob storage accounts. Key Vault is the dependent service we use there. And then we also have Azure Application Insights. And this is a service in Azure that lets you track metrics on how your APIs or how your services are performing. So you get to see how users are interacting with your service, whether how many times they're actually succeeding and how many times, there are errors occurring and what type of errors they are. So that is also a dependent service for Azure Machine Learning Services. And then, of course, as I was referring to before, within the Azure Machine Learning Services itself, we do have the terminologies around experiments, wherein any training run that you do can be packaged up into an experiment so that you can actually track all the different types of runs that you're doing and also do comparisons between them. Similarly, we have pipelining, wherein you can actually pipeline a series of steps that you perform, right from model acquisition to data acquisition to data preparation, model training, and model deployment. So all of these series of steps can be created as a pipeline, and the pipeline can be published as an endpoint so that you can actually trigger the series of steps from any REST capable services. And then, of course, we have the data sets, models, registry as well, and also the endpoint deployments that we're going to talk about further down in the session. So with that, let's quickly go about into the Azure portal. Let's see how to get started by creating your first Azure Machine Learning workspace. So with that, let me go to portal.azure.com. Okay, so in the Azure Machine Learning, in the Azure portal, let's go ahead and create a Azure Machine Learning Services workspace. I'm going to search for, oops, sorry, I'm in the wrong screen. Azure Machine Learning. Okay, so let's go ahead and create. And if you're already familiar with creating resources in Azure in general, so you typically would see all of these different services. TA live. Um, so that's my resource group name, and also I'm going to use also going to provide the workspace name for this particular session. So that's my workspace name. Choosing a region. Again, keep in mind that whenever you're actually choosing a region for your workspace, it's always good to create the workspace closer to your data. So let's say, for example, if your business data is located in Australia East, we always recommend customers to go ahead and create the region in Australia East so that some of the computes that get deployed also get deployed in the same region and you don't have to worry about data transfers between regions. And as I was referring before, here are the dependent services like the storage account, Key Vault, application insights, and container registry that get created while we create the service. Or you can also use your existing services as well. And then of course we have connectivity, given this is machine learning and we are going to deal with data while we do this. uh, we need to make sure that we are able to protect all the services, behind a virtual network, so that the data is protected, so the service is accessed securely. And that is where you have capabilities to integrate with Azure private endpoints as well. But for today's demonstration across, Mir and I, both of us are actually going to use a public workspace so that we can show you some of the development capabilities. We already have a session that was published specifically focusing on enterprise readiness. So we always encourage you to go and check that out. So with that, let's go ahead and create a Azure Machine Learning resource. So once you have the resource created, that is when you will actually have this particular studio experience available for you. This is already an workspace that I have pre-created before. You can access this workspace once it is created using by going to the URL ml.azure.com. So this is a studio experience where you can actually interactively perform steps like running your own notebooks, creating automated machine learning experiments, registering your data assets depending on where your data is located, whether it is located in Azure storage accounts or Azure SQL databases, or whether you would like to upload some of your data assets from your local machines as well. And then of course the jobs and experiments, as I was talking about, we will go through some of this in detail later in the session, but I just want to quickly show you how this is actually structured. And although the UI is a primary way, one of the supported ways of interacting with your Azure Machine Learning workspace, what we are going to focus today and show you all the demos across are how to interact with Azure Machine Learning workspace as a developer using the Azure ML SDKs and the CLI. So the SDK for Azure Machine Learning services, we do have SDKs in Python, .NET, and Node.js. And these SDKs will help you interact with the workspace programmatically so that you don't have to use the UI, and also will help you in implementing your machine learning ops, going forward, as in when you are actually building your machine learning use cases. And if you would like to include GitHub and perform all the operations automatically for retraining and model deployment, model validation, and do all of that end-to-end MLOps process, that's where the SDK and the CLI are going to be really helpful. And that is what our session is also going to be focused today. So with the SDK, what you actually have to do is, here is a Python SDK that you would just go ahead and install. And then, you can actually authenticate with your workspace by providing your credentials, your subscription ID, resource group, and workspace. Mir is actually going to show us through some of the cool demos on how to go into the details of this. And the same SDK can also be used to run your jobs, register your models, manage your AML resources like data assets, AutoML runs, and perform pretty much anything that you could actually do from the UI using the SDK. Similarly, we also have a CLI experience. For some of you who are actually, are familiar with using the Azure CLI, and would like to implement some of these automations using the command line interface rather than writing it up in Python, the CLI is a great place for you to be as well. And it's also particularly helpful when you're implementing MLOps. And as you can see here, once you have the CLI installed and ready to go, these are all the different type of commands that you can actually perform against your machine learning workspace. Again, similar to the SDK, you can train your jobs, you can deploy your models, register your models, create your development environments, track your model performances, and do pretty much anything that you are doing in the UI. So this is the baseline of what we're going to discuss today. And I will let Mir run us through some of the demos to show you how to use the SDK and the CLI. And then at the end, we will also discuss some best practices for developers that are using Azure ML. Over to you, Mir.
Thank you. Thank you, Varma. So once the workspace is created, let me take you to the journey from the workspace itself. So I'm not going to spend more time on it. I just wanted to point out that this is a control plane for your Azure Machine Learning service, but most of the data science activities will happen in the Machine Learning Studio. One thing to note is that for a data scientist to get access to the Machine Learning Studio at a minimum, you probably will need a permission that someone in the admin role need to assign, that is data scientist roles. I just want to quickly show this before I go into the machine learning studio. So it's like job function as a role. You just search for as your data scientist role, and there are obviously you can customize this role just, but yeah, at a minimum you will need this role to get access to. Otherwise, you may not be able to get to the machine learning studio in the first place. Just want to point that out. Of course, you go select that role, assign the role to a specific person member of your team, and then of course once this comes, like if I say Varma, I want to give Varma the access. Uh,
Thanks, Mir. And Mir, I think we also have capabilities to add custom roles as well, wherein you can
Correct.
actually create a custom role
Yeah.
with specific set of permissions on the workspace itself, right?
Absolutely, absolutely, and that's the beauty of when you feel like, okay, I'm not gonna give very open permissions or access to an individual of my team. You can always come and look at, okay, what is the minimum that you need. That's what we recommend as best practices. What is the minimum access this particular role needs to perform against the machine learning service? That's where the customized role comes into play. But just at a minimum, you have to look at, okay, this is how you need to specify the permissions before they can get into the machine learning studio. Once we have that, obviously I'll skip for the sake of time, but you just review and assign, and then that person will have access to the machine learning studio. They will be able to go to the studio. But going back to the machine learning workspace that we created, all you have to do is click on launch studio. You could go in the other way, and Varma already mentioned this, but if you click on the launch studio from within the workspace, it will take you this machine learning studio view. For the sake of time, I'm just going to quickly go into the developer experience part. But again, most important to keep an eye on is your compute resource. Uh, if you would like to work with the assets that we have from within the Azure Machine Learning Studio. If you want to do it from locally, you'd have to set up your local environment. We have a good documentation for it you can walk through, but just want to quickly point that out. And then obviously all these data sets are assets are very important: data, jobs, components, pipelines, environments, models, and points. As you go through the demo with the Python SDK first, you will see that all those are getting lined up one after the other for the end-to-end lifecycle of your machine learning model within the machine learning service. From the developer perspective, we'll focus on notebooks. So I'm going to go to the notebooks tab. Two things that I want to point out: these notebooks, obviously, it is a file share from the uh, blob storage that being created as part of your machine learning studio creation or provisioning. It was obviously required property that you need to set up, meaning you have to create a machine learning. In the process of creating the machine learning workspace, you have to create a blob storage. You can create a new one, or you can use an existing one for that purposes. But that's where a file share will be also created, and your assets, your files, your notebooks will be mounted on that through that file share onto the computer of your choice. Now, two things also I want to point out is that if you have your own files that you want to bring in, there is a process that you want to bring the files here. You could simply say, okay, I'm going to go ahead and upload, right? You can just upload the files. That's fine. That's one way to do it. But let's just say that you have a repository where multiple of team members actually get together and they share their development activities, right, on a specific project. Then obviously you're looking some kind of tools like GitHub, and to get the files from the GitHub, we can use the Git commands. That's Git integration. There is a documentation for it as well. And Jamil, if you get a chance, share that Git integration documentation. But for us, I'm going to quickly show you how we can do it. The idea here is simple, is that if you have a known repository that is already part of samples, all you can do is you come here and select that particular, like for example, for me, I looked at the SDK v2 and then clicked on the clone path. If I clone it, if I click clone from here under the samples, it will come under the under my user ID, under this file hierarchy, right? So I have two of them. Though the Azure ML examples that you're looking at, I did it through the command line. I'm gonna go get to there in a sec. But just want to point out there are two ways that you can get to those files. Now, once you have a file, if you open a file from here, let's just say I want to open tutorials from the tutorials, and I want to open Azure ML in a day, and I want to solely work on the Python notebook, right? So you open the Python notebook right away, look at the option that it gives you. So I'm gonna minimize this one for a second. Uh,
So Mir,
Go ahead.
just while you do that, so the notebook experience that you're actually showing us now, so that is different from a typical notebook experience like Jupyter or Jupyter Lab, right?
No, this is the Jupyter notebook experience, not the Jupyter lab experience, so to speak. If you look at the Jupyter lab option, what it is, it's essentially taking you inside the Jupyter lab where you can open the. It's almost like a VM that you are getting access to with the what you call the visual experience, like UI type of experience you can interact with. What I'm showing right now, it's a notebook experience to the Jupyter. So for instance, I didn't go to the compute, but for instance, if you go to the compute and if you create a new compute instance where it will act like your own data science VM within the machine learning studio, then first step, of course, you just create the compute instance. You follow the steps, you create the compute instance and create the instance that you need based on the type of activities that you want to perform. You can start with low, of course, and then figure out, okay, I need some bigger configuration with a number of more cores and memory. But once you cancel that, notice once it comes online, it gives you the options of interacting the applications that you want to leverage to interact with your compute of choice, compute instance of choice. You could just go to the Jupyter Lab, Jupyter Notebook, VS Code, VS Code Web, and VS Code. If you click on the Jupyter Lab, this will use the typical traditional Jupyter Lab experience, right?
Yeah.
That is almost like there's a Jupyter server behind the scene that's working for you, and you go look into your files, and then you find your, for example, I was going to the tutorials, and the tutorials getting into an experience. I was looking at this one. This is one experience for sure. You can work off of that. What I was showing it is that from within the notebook, without going to the Jupyter notebook view, notebooks that you have, you can directly interact with it, and you can essentially come here and you can see the option that you have to go through. Basically, it's no different than having a runtime where you can go through your notebook and run it one cell at a time. You can run all the cells available, but that's the
That's great.
developer experience that you're looking at from few different angle,
So,
essentially.
so if I have to summarize, what you're actually saying is the compute instance on Azure Machine Learning Services is a virtual machine that is pre-configured with all the required Python environments and some of the development applications like Jupyter and Jupyter Lab and VS Code integration, so that I don't have
All
to do that and go through the hassle of struggling with installing packages and
absolutely.
dependencies and all of that. So that's a virtual machine that will actually get me started right away. Can you show
Absolutely.
us quickly on how to create that?
Yes, absolutely. So for to create that virtual machine, I call it a data science VM rather than just simple virtual machine,
It
because
is,
that's what
yeah.
it is essentially. You go to the compute tab, and essentially under compute instance, you click on new. You just go through the process of the just give it a name that suits you based on the naming convention that you practice. It could be a GPU or a CPU based virtual machine. You can select from a recommended option, or you have much more selection options that is available for you. Those are the VMs. One thing you probably want to keep an eye on, these VMs actually coming from the quota, overall quota that you have available on your subscription. So if you exhaust the quota, you may not be able to create a VM. So your admin would have to essentially keep an eye on how many cores we have available for this whole subscription, and how many of those cores are essentially available for the VMs that you need for the data science activity, just for the best practices. Now you select one. Let me go back to the pre-selected one. Let's just say I want to have a very general purpose one with the minimum configuration that I need, because I'm just doing basically I'm just doing a POC with this very small scale model development activity. So that's how you just start with. But then obviously to figure out from the production grade machines, while you have a machine learning model that needs more core or more memory, you need to benchmark it. But anyhow,
And
you select it. One sec, Verma, you select it, and if you go to the advanced tab, one thing I wanted to point out is that an admin has an option to create a VM
mm,
and assign it to other users. You can have some kind of provision in setup script that could be run in the beginning phase of your machines. If you want to have some kind of custom library installed, you can enable the SSH access. At that point, it almost like it is a remote VM for you. You can just go to the remote VM from within your local machine as well to perform any activities. Okay, I'll pause for a question. Go ahead, Verma.
no, I was just actually going to ask that and say that, I see some of the customers who are data scientists, but they do not have the ability to actually create these compute instances or the compute clusters themselves,
Hmm.
because the IT, would also obviously like to keep a tab of, what sort of VMs are actually getting deployed and how they are getting deployed, whether they're being deployed with the virtual network enabled, by assigning a managed identity and stuff like that. So they pre-create these compute instances for them, and I think you have just shown that option to us. Thanks.
Yeah, fantastic point. Fantastic point. Absolutely. We have multiple options that even if you want to, for example, keep it shut down after a certain time, we actually add an option to add a schedule on when you want to get it started and want to get it stopped, so that you don't incur unnecessary bills. Yes, you can manually start and stop it, but at the same time, we also have a schedule way of starting and stopping your compute instance. Cool. So in the interest of time, I will just cancel the creation because I already have one that I'm going to work with. But once you have that compute instance of as next thing you want to do as part of your machine learning model lifecycle is you want to start developing, right? So you go to the notebooks. So what I'm going to do today is that a few things I want to point out before I go to the next step is notice that this notebook automatically attaches to the current active one. Okay, that's one thing that you need to you probably will see it right away. The other thing I want to refer to is the kernel that is being used. Now, it may be possible that if you use previous kernel like Python 3.8 and Azure ML, you may have to run that command to install the Azure ML SDK and CLI uh, v2 installed through the pip command. You may be able to, I may have to do that, but our kernel 3.10 already includes SDK v2, so you don't have to worry about that part of setup. That's one. That's number two. Number three is, of course, there are multiple options that you want to probably take advantage of. Like, if you want to do operations from here, you can do so. There is a way to convert this Python code or on the notebook into Python code. You could take advantage of these options. So my point of saying this is that it's almost like another development environment within ML Studio solely for the purposes of working with notebooks, converting it between notebooks and Python .py or strip files, things like that. There are other options that you can also restart your kernel as needed. If you run a command that installs a new library, you most likely you'd have to restart the kernel. You can interact from within this interface. Okay. So now that I have an example notebook, I know how to interact with it. The third thing probably is most important for us to walk through is that you really do not have to do it from here. You could essentially work with your code within the compute instance from within your laptop using the VS Code. So that I'm going to click on the edit in VS Code for this particular Python notebook that I have. This is an example notebook. Before I go how I got it, obviously I showed you that I just use the sample step here, but there is another way to do that. I'll just come back to that one. For now, let me open this in a Visual Studio Code off of my laptop. I'm going to use the edit in VS Code view.
Wait, do I have to have any plugins that needs to be pre-installed with my VS Code?
Great question. I will walk you through that process. Let the um, VS Code first open. So, but it's a great point that you mentioned. I will just go through the extensions tabs to point out few extension that we need. What I would like to point out, once this VS Code opens up, there are a few things that you see happened already. It's for me, it was already set up, so you're not seeing it. For example, the Azure extension got installed, and that's how I was able to sign into the Azure with my credit. Second thing is it essentially uh, bound to the workspace that I already have. So workspace is the same as you showed us. Workspace is the central place where all the assets regarding machine learning lifecycle are stored and managed, right? So I need to get to the workspace before I can look at anything, right? So that's why the workspace setup was in place for me. You could just click on workspace setup and you can select the subscription that you want to select from, and then of course it will show you the workspace that are available. For me, of course, I'm not going to make any changes. This is the one that I have, so I just keep it that way. And the other thing is it is the uh, remote attach option. To do the remote attachment, you'd have to few extensions install, like for example Azure Machine Learning remote
Hmm.
attachment option that needs to be there. Also have few other, like I have a Jupyter environment created. I think that's not coming into place. All it is for now is just a way for the VS Code to interact with the remote VM. In this case, my compute instance from within my local machine is where this extension comes into play. This is what I have. Okay, it's a great point, Verma. So now that I have the code, I have the code, VS Code ready, and I have the notebook ready. All I want to do next is I want to perform the end-to-end life cycle of my machine learning code. In a way, it's put into a Python notebook. That's how I'm going to show it. But you could easily create a Python script where you have all your code will be, and then you can refer to that code in a job command. So that's what I'm going to walk through slowly. Um, let's look at one step at a time. First thing you need to have is you need to have the connection to the workspace. You could have that connection going to the portal, but we have a programmatic way in this notebook that we can use whenever you're a data science scientist. You want to interact programmatically. You use either Python SDK v1 or v2. We are showing our examples in SDK v2 today. The core of this v2 API is ML client. You just first need to make sure you have the reference to the ML client object. To get the reference to the ML client object, of course, you need the credentials, you need the subscription ID, and you need the workspace ID and the resource group information. So we created the credential object here. And then once I'm ready with, I have subscription ID, resource group name, workspace name, then I am ready to create the ML client because I already have the credentials. That's the next thing that you do. So your workspace, then from the SDK usage perspective, first thing you do, you create the ML client object. To create the object, you need the subscription, resource group, workspace, credential. You put that in. Now you have the ML client ready. Okay, so next thing you want to do is essentially, as part of your training process, you create an ML, create a job. Essentially, the job encapsulates the code, the environment, the compute, all of those, right? So to create the job, first you need to have a target compute where you're going to submit the job. That's what I did here. I created a compute cluster, but notice I'm using the Azure AI ML library. It's a V2 construct, and the object that I'm referring to is AML compute object. I use that object to create the target compute where I'm going to be submitting my ML job, train ML training job. Once I obviously it's a configuration, I'm not going to go to the details. I have this compute, it's no different if I go back simply to the environment. It's no different on coming here. So let me close this one and coming here and going to the compute tab and say, okay, I'm going to create a compute cluster. So I have two clusters ready, and the process is almost the similar. It's almost the same as we had in compute um, instance. You specify your CPU GPU requirement, the VM node. One important factor that you need to keep an eye for the compute cluster is that you can specify the minimum and maximum, and this is an important consideration. You can start very low, you can go as high as you want to. So I think we probably 24 or maybe more right now. I have to check the documentation, but there is a max number of nodes per cluster that you can create. Other than that, the other operations that you have, you can definitely enable the SSH key. You can have you can have this cluster within the network, virtual network that you configure. All those good stuff are already there, but that's what you do. And in the code view of it, I am exactly doing this. Actually, this one, I'm doing exactly that. I have the compute target name. I have the type of the computer. This is the VM size that I'm selecting, min node, max node, and of course, it's going to be a dedicated tier. You could have a like low priority tier if it is just a development, but for the production, of course, you have to make it a dedicated tier. So once you have those ready, just create the cluster using the command compute. Notice the hierarchy, the client, the compute object, and then off of the compute object, you have begin or create as the API call to create your uh, create your compute. Once you have the compute, then what you need is an environment. What is an environment? Essentially, it is the environment that is required for your machine learning model code to run. What kind of Python libraries you're using, right? That kind of thing. So obviously, this is the dependencies location, but most important is that you are creating a conda file. Please note that you don't have to use the conda file. We have a curated environment. So I'm going to show it once I go through this code base. We have the curated environment. You have a conda file that you create specifying, and this is an YAML file for specifying the dependencies for all the libraries that you need to be used for your model. For the current model that I have, these are all the libraries. That's how I specified it. The conda file will be created if I execute it. So I can try executing it just to show you it is executing fine, and probably I won't have much time to execute everything. But if I just say shift enter, it will so it is asking me for Azure ML Compute instance, and then I'm gonna go this. It will find me from this cluster. This is the one that's running. That's what it's going to be attaching to. And then I'm going to use the Python kernel. This is the one that's recommended. So it's going to start executing off of that compute. Okay, so notice how easy it is. You don't really have to create your own data science VM. Everything is ready in the compute. All you have to do is create the compute instance, attach it from locally within your VS Code to start working on your code or on your development cycle for the machine learning model. Now, second thing, of course, I have the library specified. I create the credential object. I create the ML client object, and so on. Again, I'm not going to go to the all of them, but that's how you start. You have uh, the ML client object, you have the compute, you have the environment that gets created through this command. I can easily run this and get this created. Of course, it's going to probably fail because I didn't run the previous one, so I have to run this one, and then I can run this one. Yeah, right. So then, of course, when you have the environment ready, there's an environment object that needs to be created based on this conda file. Once you create that, if you execute this line, this environment will be created and be put under the environment tab. So let me quickly show you what it goes through. If you go to the environment tab, under the Azure ML Studio, you will have curated environment, which is what I created through this the execution. And I mean, sorry, custom environment, which I created through the execution, and you have the curated environment. We believe almost most of the scenarios of your uh, uh, machine learning usage, machine learning model development usage would be available under one of these curated environment, but of course we have an option to do the custom environment. That's what I was just showing you.
And I
So
think,
going,
and I
go
think
ahead.
for customers, I think definitely going through the curated environments, just so that to identify if there is already an existing curated environment with all the necessary packages which suit their requirement exists. Mainly, I mean, I usually recommend that because if you are going to use the curated environments, the image is already built. It actually exists in the Microsoft Container Registry, and that kind of speeds up your training job, because now all you're doing is pulling the job in, pulling the image into the compute instance or compute cluster to run it. However, of course, not all scenarios are compatible with the curated environments. So in those cases, when you go out and build your own, configure your own custom environment, what happens is at the start of your training job, there is a build process that happens for the image for the first time. So it does take an additional few minutes for the image to be built and then pulled onto the Docker container, sorry, running in your compute instance or compute cluster. So that's something to definitely keep in mind.
Yeah, as a best practice, definitely I would recommend that just look onto the list of curated environment first. If you do not have it, then yes, go ahead and create one that is required for your specific scenario. Great point. Thank you for sharing. So again, so now that you have the environment ready, next thing is basically create a script your model training script, so to speak, for a specific scenario that you're trying to solve a problem for, right? So you just create a folder structure for your training script once you have the folder structure ready, and then you have the main code created on a Python script file from within the notebook itself. Once you have that code ready, and in the interest of time, I'm not going to run it. I already have a job. Let me walk you through the entire process end to end, so you have an idea with the life cycle. So once you have that script ready, next thing you do is you create a command job. Essentially, there are few types of job that you'll look at, but command job is the simplest one that helps you submit a training job to the machine learning server that, hey, I need to create a model using this training command. As you look at it, it's essentially there are a few things of noteworthy. One is, what is my code? uh, what data sources that I'm referring to, the parameters that I need to pass on, and then at the end of the job execution, the register model. What is the model that needs to be registered at, right? Those are definitely worthy. But then look at the command. It is nothing but a simple Python command. It's Python, and then obviously you refer to the Python notebook that has your code, and then you specify the parameters for the data. For these parameters are for the parameters that you need. Uh, as you're passing in around the parameters for the model I'm referring to. You are passing in as the parameters for this command job, but these parameters are for your models that you also essentially coded. So if you look at the code, so you have those parameters. So that's how they are related. Okay, so but you have to specify those as needed. Once you have that command job created, you submit the job to the same ML client create or update. As you note, it's already been created for you, so I didn't want to run it, but I just want to show you. So you submit the command job, the job gets started, and if you look at where the job goes, essentially under the jobs tab, all jobs will be there. There will be name for the job under which all the job runs will be essentially recorded. Like in this case, the experiment is chain model create default, and if I have multiple runs, these failed, these two worked for me. All of those were recorded under the jobs, the experiment name that he used, right? So that's where it's gonna go to. Now, if you go back, once you and if you want to essentially look at each job, you can go into details again. If one interesting idea might be, okay, I'm gonna look at the matrices, then I'm gonna look at the outputs and logs. If you look at the outputs and logs, it will probably give you more information on if it fails, what do we have to do, troubleshooting wise. But that's where you can find the jobs, and it gives you some tips as far as where you can find it, etc., etc., right? Uh, okay, now you have a job created. You will also see the model that's created. So if you go to the models tab, you definitely have the models created for you. And there's a version 2, version 1. So in terms of model registry, that's what it does. It just keeps track of all the models that you created with the versioning capabilities, so that you can then go into details about okay, what version I want to use. And if you want to deploy right directly from here, you can do so. But for our purposes, I just want to see if I can deploy the model to an endpoint. There are multiple options of endpoint. I'm going to use the managed endpoint for today, and managed endpoint simply means that it is managed by Microsoft. There is definitely a compute behind the scene, and that you can select and choose. But the idea is simple, that you don't have to manage it. Microsoft will manage that endpoint for you. All you have to do is run the job, right? I mean, run deploy the machine learning model on it, not run the job, sorry. Deploy the model into that endpoint so that it can infer, and it can do the perform the inference activities against it. So that's why you just create the endpoint. uh, keep an eye on this one, because endpoint is just the placeholder, but at the end, the deployments is where you're going to look at, okay, so I have two different deployments, blue deployment versus green deployment is that also helps you essentially doing the testing against each of those deployments and make sure you finalize which version of the deployment gives you the highest performance. So from the end-to-end perspective, you get the data, pre-process the data, train the model, register the model, and then once the model is ready, you deploy the model. Endpoint helps you deploying the model to create an endpoint for you, where you can do the inferencing activities, perform the inference activity. So I'm just going through like it's a manage endpoint option. We have other options as well. I created the endpoint and then obviously it's a description. Then you just have to use the online endpoint option to create the endpoint. There is an option to the batch scoring endpoint as well, but I'm just going through the online endpoint option here. Once the endpoint is created, notice how we deploy the model to that endpoint. That's what I was referring to. Its endpoint is a placeholder. Deployment is where you have the model on that endpoint listening for a request for inferencing. So we look at the latest model. Then we get the model. After we get the model, I just create the blue deployment and then I deploy my model onto that endpoint. Once that's available, I can easily do the testing against that endpoint. So that's the activity. So for example, I can run this command to uh, do the inference testing. I could also do this. Now that I have the endpoint created, I can take this input and I can go back to my portal and I can say, okay, so I have the endpoints. I'm going to look into one of my endpoints. I'm going to do some testing. How can I do the testing? I can just put my code here and I can say test. Since it is already available. I didn't run those codes, but I mean, it's one after the other. The code is very laid out. If you go through the tutorial, it will give a very good view of how you go end to end in one simple notebook for starting from getting the data, training the model, registering the model, deploying the model, and do the inferencing activities from within SDK V2 itself. Okay, just wanted to quickly show you that part of it. Now, if you need to look at some of the coding aspects, notice it just actually give you some code snippet as well, right here within that deployment from within the Azure Machine Learning Studio. You can take this code and you can also do the same kind of, you can put together a Python script or an application and essentially um, do the perform the inference activities through your application of choice. Okay, I'm going to pause for a moment if you have any observation, Varma, if you want to add something.
Yeah, I just wanted to ask, since you mentioned that there is endpoint and then there are deployments within the endpoint, can
Mhm.
I have multiple deployments for the same endpoint?
Yes, absolutely you can. And then once you have the deployment though, but you have to make sure that when you are sending a request for inferencing, you just go to the uh, relevant deployment rather than going in I mean, if you don't specify the endpoint deployment name, it probably won't find it. So that's one thing that you need to be aware of. But as I was saying, it's right now I have a blue deployment. I could also have a green deployment. So both of those
So
deployments can go to the same endpoint, essentially.
yeah, okay. So that will basically allow me to have functionalities like being able to perform A/B testing
Correct.
or traffic balancing and other functionalities.
Absolutely correct. Very good point that you mentioned. Yep. All right, so that's the SDK way of essentially deploying the job, uh, or rather, I want to say that end-to-end life cycle of a machine learning model, starting from gathering the data, training, and all the way to deployment and inferencing. What we recommend is rather than using the straight scripting way of doing the development, you take advantage of pipeline. So we do have an a notebook that gives you essentially end-to-end pipelining experience. Uh, I'm just looking at this example. As you can see, uh, all I'm going to point out here is that the main important step to note in comparison to Azure ML in a day Python notebook, that the example that I went through, is you are going to leverage the component concept. What is component concept? Essentially is essentially a unit of code that is repeatable for you, that you can put it there. So for example, you need to do the data preparation. Put your data preparation code in a component. Make that a repeatable component so that you can stitch. Sometimes you may even reuse it for other pipeline as well. So that's why it becomes important that you just uh, com- create the components for that type of reusable code. Now, training probably will be individually different from each of the pipeline that you produce, but now you can have a pipeline where you have data preparation, data gathering, data preparation, then the training. Once the training is complete, of course, it creates the model for you, and basically creates registers the model into the machine learning registry, right? Machine learning server registry. But that's the probably main important takeaway of pipelining it. So if you want to create the pipeline, of course, I have the data preparation as a logic, code logic that I need to work on. You could even further, like in this case, I'm just doing the data preparation. You could also probably create a data access separate component, but data preparation is one component for me. I create that component, and then to there's a process to create the components like data prep component. This is the command that I'm going to be leveraging. Once it is created, though, it will be a reusable component for me.
Yeah,
Same thing is,
that's
go ahead. I'm sorry.
now that's great. I'm actually excited for the new functionality called Azure ML registries as well,
Hmm.
where now we are actually seeing customers share these components not just within the same workspace,
Hmm.
but also reuse them across multiple workspaces in the organization. So,
Good
which
point.
means I might be a data scientist sitting in a team. I've developed a specific component that's going to use a specific algorithm or do a specific data preparation task. I can actually register that as a component in the registry that is shared across the workspaces, so other teams can actually reuse it and
Hmm.
and 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 take advantage of that as well. And I have seen customers do that.
Yeah, very good point. Very good point. Thanks for the pointer. So again, that's the main takeaway. In the interest of time, I'm going to quickly go through it. Like you see, you have a train.py file, and that's being separated out. And we created essentially a different way of doing things. We are using train.yaml file to create that component. So this is where probably you'll see that reference of how do we do it in a CLI way. You could create a definition of train job in an YAML file and then invoke that YAML file to do the training. This is where the reference comes in. So we are creating this component, but we are using actually YAML file way of defining what is the component going to look like, how we're going to do the training for this particular component that we have. So the code wise, as you can see, this is my train.py file, script file, but I'm going to use the command to run this train.py file, but I'm going to define the command using the YAML file. That's where it relates to. So I'm just defining how I'm going to run this particular script. But once I have that, then I go and create essentially I go and create this component for me. Once the component is ready, then I'm going to stitch those components together. So as you can see, you'll see have the pipeline is being created. There are two components for the pipeline. One component is data prep component. The other component is the train component. I stitch those together. I have an end-to-end workflow that essentially mimics the life cycle of machine learning model, starting from getting the data all the way to registering the model into the model registry. And to your point, of course, if your goal is to have the shared model registry, fantastic. Then you have a reusable models that could be shared for multiple projects. Okay, so that's the main thing that I wanna share on these particular aspects. Um, but if you would like to, essentially, let me show you one thing real quick before I hand it back to you, Barma. Let's just say that you want to do everything in CLI, right? So let me show you. You can go to the CLI tab in the example repo that we have under the jobs tab, uh, and then we have basics. I'm going to go with the basics, and then let's just say I have source. Actually, let's see which one. Endpoint, scroll down, it's one sec, jobs, standalone jobs. Oh, which, where did it go? Source. Like in this case, if you look at the way that hello, even if you look at the um, hello dot iris, let's look at that particular machine learning code that I have, right? I have the script created. Now I also have the what you call the YAML file, hello.iris YAML file created that defines, okay, this is the job that I'm going to run, right? So I'm defining the job that I want to run. Iris.csv is the file, but this is the URL file type. Uh, this is the compute target that I want to leverage. The command wise Python hello.iris, that's the command. But now if you want to submit that job, so let me see, what is this location? City to Azure, city to CLI. Now, if you go to, what is the location basics?
Try the standalone jobs, maybe.
LS, city2, is it under, I didn't see the reference, one second. Okay, I lost the example that I'm looking at, but let me see. Very quickly, single step, actually, let's see.
That
Scikit-learn, Iris, and this actually gives it a very good view of. So I had it is under CD2 single step. It is under CD2 jobs, right? Okay, so now if I want to deploy this job, all I can say is okay, and CD2 uh, single step ls CD2 scikit-learn ls CD2 iris plus. So all I have to do, Azure is the ML job create dash F, and then specify the job.eml file. Let me look at the example real quick just to make sure I have the right example set. One second. I'm gonna go back to, so if I look at the example here, CLI, and obviously it will show me the job, but it's, if you look at the way that, how do I run the job, this is the command that essentially we need to send. Okay, I can just copy this. I can come here in my Visual Studio Code. Uh, Let me just paste it. And
you might
instead
you
of,
might you might want to move back on the folder, but yeah.
yeah, so, but I don't really have to. All I can say, okay, because I'm already in this folder structure, all I have to do is just to specify the name of the file, job.yaml file. That's AZML job create, and then that should do. They should start a job. in ML service, and then we should be able to see it like, okay, so it's already uh, created a job. This is the name, musing rotate. That's the job ID. So if I go to the jobs tab, then it should come here, uh, and there should be new job queued, right? So that's how you can do the once you have the most important point is that you create a structure of your code, depending on how you want to perform the end-to-end lifecycle, either SDK way or CLI way, then organize the code and use the relevant commands, and then use them both from the tools like VS Code or right within the ML Studio. You could just go to the Jupyter Lab, or you could just essentially just go to the notebooks experience, and you can just perform the end-to-end lifecycle. So I wanted to show all those goodies so that it becomes easier for a new uh, data scientists coming into the ML. New in the sense of ML, Azure ML is the new service that they're interacted with. How easy it is to get started and get going, become productive very quickly with the Azure ML service. That was the goal for me. So at this point, Varma, would it be okay to request that you just go and share some of the best practices with us? Because I mean, of course, you have all
Absolutely,
the,
absolutely.
yeah.
Thanks a lot, Mir. Thanks for that detailed walkthrough on the SDK.
Thank you.
Todd, do you have my screen up? Yep. Okay. So, yeah, also I just want to highlight before we jump on to some of the best practices. I would like to share this repository that Mir was actually walking through with some of the samples, the Azure ML examples GitHub repository. And this is actually an actively maintained repository from our Azure ML product team. As and when new functionalities are coming through for the SDK and the CLI, this repository does actually get an example based on that new functionality. And just to also go through, say for example, if I look at the SDK, specifically the Python SDK, you have examples segregated based on the different actions or different assets that you can interact with in Azure ML. If you go under assets, you can actually see how you can work with the components as a functionality, data registration, how to consume data within a job, how to create environments using the Python SDK, how to manage them, and how to manage your model assets as well. And similarly, in terms of jobs, we also have examples that actually explain you how to trigger automated ML based jobs in Azure ML, how to use single step, as simple as single step jobs that actually train a PyTorch model or a TensorFlow model. What are the configurations that you need to take care of when using a compute cluster for distributed training? And then, of course, we have pipelining functionalities with different scenarios. There are pipelines with just direct command jobs, but also pipelines with components that are actually being used. And then we have other types of jobs like distributed jobs and other components. So we definitely encourage you to go through this repository as in when you are getting your hands dirty with the CLI or the Azure ML SDK v2. So with that, I would like to quickly share a couple of things that we see our customers, using, as well as some of the practices to accelerate the dev experience that you have with Azure Machine Learning services. Now, first and foremost, um, in the Azure Machine Learning Studio, I would encourage you to take a look at this icon here with the new announcements, where you get to manage some of the preview functionalities that the product is releasing. Of course, not all organizations do allow using preview functionalities, but this is something to take a look to understand what are the new functionalities that are coming to Azure Machine Learning services. And if you look at here, earlier, Mir had actually showed you an option where you can set up a schedule, start and stop schedule for your compute instances and compute instance and compute clusters, so that you don't have to leave your compute instances running all the time and bear the cost for it. um, but with there is also an additional functionality where you can enable an auto shutdown of the compute instances or the dev machines based on idle timing. You can actually configure something like if the machine is actually idle for 1 hours or inactivity, go ahead and actually shut that down. Do not keep that alive, so that you can actually save on cost. And again, given it's a dev machine that gets spinned up as and when you come back, you can always come back and manually start it, or have a restart schedule assigned to that as well. Now the second one is around optimizing for time to run your jobs. Now when you're specifically using compute cluster to train your machine learning jobs, usually what happens is, of course, to save the costs, absolutely, it's always better to have the minimum number of nodes as 0 and the maximum number of nodes depending on how parallel your job is going to get. However, you can also use the idle seconds before scale down. So if you have this as 0, if there is no job running or no activity happening on this cluster for 180 seconds, then it will scale down to the minimum number of nodes, which is 0 in this case. However, when you as a developer are actively experimenting with different configurations, and maybe going back to your data, cleansing it a bit more, and then coming back and running an experiment again, what happens is, if the clusters go back to 0, whenever you're triggering a training job, it does take a few additional minutes for the compute to be provisioned, and bringing back this to maybe one or two nodes, right? So it does take some time. So usually what I suggest customers do is have this set as minimum number of nodes as 1 at least, so that you always have the compute cluster available for you to actually experiment with your code faster. But however, at the same time, keeping costs in mind, once you're done with your development work for the day, it's always good to come back and set this back to 0, so that you don't incur any costs while you're not actively using the cluster at all. So that's a quick tip that I would like to share, so that you can actually save a few minutes every time you're actually trying to spin up a job. Second, so the other one is especially around environments. So as we have discussed before, environments are basically Docker container images that are actually pulled into your compute instance or your compute clusters to run your training jobs. And in fact, Docker containers are also used in your managed online endpoints or any other endpoint deployments that you're doing. Let's say, for example, you're actually using Kubernetes as your inferencing option. uh, Whenever you choose that, and whenever, let's say, I go to my models, and this is one of my registered model, I select that and I actually choose one of the deployment options here. What happens is, when you choose the deployment option based on the type of the model, etc., it these information, the model file itself, and the deployment configuration as to what environment it needs to run under, and the compute and the model file itself, and the scoring.py, which is the file that actually is used by the inference server within the endpoint. All of them do get packaged up into a Docker container, and that is where understanding how the build happens of these containers and how to optimize for that is also is also an important thing to understand. Again, curated environments, these are all pre-built. And if you look at one of the curated environments here, actually, let's take a simple one, maybe scikit-learn. Yep, so scikit-learn, I think all of us are familiar with it. So this is one of the curated environments. This is actually an environment. Just a sec. Yeah, so no, this is actually one of the simple environments, right? And if you look at the context here, this is actually based off of a base Ubuntu image. and it's installing some additional packages using the conda dependencies. It also has the Azure ML defaults and some of the Python packages. So this is already pre-built and ready to go, so that the time you're going to spend is in pulling the image into your compute instance or cluster. However, when you're using, let's say, for example, when you're actually building your own environment, what happens is whenever you actually change, let's say this is my environment that actually was created when Mir was actually running the example. So this is the exact same environment that got created. As you can see, the Python packages, scikit-learn, scipy, and pandas, etc. Now let's say, for example, if you would like to add an additional package to this environment, right? Maybe you forgot that, maybe you need to add pillow or some other package that needs to be there for your training job to complete. Whenever you want to add a new package, if you just modify this from here and do an initiate a rebuild, what happens is it will actually rebuild the whole image entirely. And it does take some time. Typically, when you trigger your machine learning job, first the compute needs to be provisioned, then the image build needs to happen, and once the image build is complete, that's when the image gets pulled into your into the job. So to save some time over there, what you can actually do is, if let's say this is the image that you have already created, right? So now you can see here this image is actually sitting in your Azure ML registry in this location. So what you can do is you can actually create a new environment. However, this time, scikit new, I'll just give it a name. However, this time, instead of using one of the base images or anything, I'll actually choose a new Docker context option. And and in the Docker context, what I can actually do is I can actually choose the option here and do installation of an additional package. So what we are doing is we are actually using the image that was built from the previous environment, and using the Docker context, we are saying that, hey, just go use that as the base image first and then run additional commands, and in this case running an additional command of installing a pip package. And this takes way less time of adding new packages to your to your environment, rather than rebuilding the same environment with additional packages in conda.yaml. Just a practice to share. And also
Hey,
there is an Mhm.
okay, go ahead. There's a question I just wanted to let you know. Whenever you get a chance, we'll just bring the question.
Yes, please.
Yeah, so I think one of our audience member is asking whether we can uh, keep an option disabled for a preview service.
Yeah, I believe so. And also, if you look at these preview functionalities, right? So these are mostly the functionalities in the UI itself, wherein some of the options like enabling the autocomplete shutdown, or be able to, just compare few things. So these are mostly UI elements, but I believe there is an option for you to disable this completely at an organization level. Maybe that is something we can check and come back. If Jamil, maybe you want to, yeah.
Take a note. Yeah, yeah. I think what my take is that it's a slider, right? You can enable it and disable it, and so you just go and just keep that disable if you are not interested on it, right? And so and it can also basically give us a feedback why you are not interested. That will also help us improving that options for the most
I
part.
mean, I think one reason I can think about is that they do not want the data scientists to actually go ahead and enable the features for themselves.
Hmm.
Rather control it at an organization level. So,
Yeah. So,
okay, so I do have 10 minutes left. So let me quickly show you some of the other important things. So that's about environments. Also, what you can actually do is whenever you are executing, okay, first let me actually open up my Visual Studio Code. Okay, so whenever you are actually executing your Python command job, what you can also do is you can actually add, so in the command job space where Mir was actually showing you the notebooks, what you can actually do is you can actually do a pip install as part of the command. So let's say, for example, you have a container image environment with all the required packages, but then you want an additional package to be installed. Rather than including that additional package in the environment itself and building the container all over again, you can actually install the package just during the runtime when the job is getting executed, using the command option. Just include the additional pip install command and the Python to execute the train.py. So that's another way to go about it. So while the VS Code is actually opening, now we also have a new preview functionality that I would like to demo, which is debugging jobs and monitoring training progress. So which means uh, while your jobs are getting executed, you have the option to attach a debugger or monitor your jobs from different applications. So currently we do have support for different applications like Jupyter Lab, or you can actually invoke the debugger from VS Code, or even look at TensorBoard. If you're training PyTorch or TensorFlow models, and you want to look at how your training process is happening as and when it's actually going on, you want to monitor and debug, you can actually attach to a TensorBoard as well. So this is a preview functionality at the moment. And if I want to quickly do that, just a second.
Just keeping an eye on the time, Verma.
Yep. And we do have examples for this already in our repository as well. So if you go under jobs and go under single step, debug and monitor. So that's the debug and monitor notebook that is readily available for you. I had to make couple of changes, but let's imagine now I'm actually going to go ahead and execute this right now. I will actually do this from the UI. Notebooks. Just making sure I have the right SDK, right kernel chosen here. Yep. So what we are actually doing here is, while we are executing the job, earlier when Mir was actually showing you the example, it was typically like Python and the train.py or main.py that's getting executed. However, when you want to enable debugging, you need to add additional things to your command, which is using the debug py. And this debug py is a package that comes pre-installed on all of the curated environments. But if you're going to use a custom environment and you would like to debug, you need to manually add this to your conda YAML or your requirements.py. So now once I have this, what I can actually do is, given I've attached a couple of applications to be part of my job run, if you go to your specific job and click on debug and monitor, you see that there are applications running. And I would like to, open the debugging from Visual Studio Code, which I can do directly when it actually opens up. So essentially what is happening behind the scenes is this particular job is running in a compute cluster, and it is actually running inside a Docker container. Now, because we have enabled these services, what it is actually doing is, it's enabling a connection from my local VS Code directly inside the container running inside the compute cluster to be able to debug the code. And we can also attach a debugger for the same, while the job is running. So it's still connecting to my remote compute at the moment.
So while it comes up, I just want to quickly say that it's the summarized view of our discussion was to essentially walk you through the entire life cycle of developing, training, registering, and deploying your models, and then all the tools that are available for you as you look into the end-to-end life cycle. That's essentially the summary of our discussion. And obviously, we'll wrap up quickly, but I just wanted to summarize what we've tried to achieve so far. I am hoping that our discussion was very helpful for our mission today.
Thank you, man. Yeah, I just have a couple of minutes to talk about. So,
Okay.
just want to show you, you know, yeah. So this is the job that I'm actually connected. If you can see here, I'm actually connected inside the container where my job is getting executed, and this is my training script as well. And I can open this file and then actually go to the debugger and then get attached to that remote compute, which is getting posted at the local host in the container, and that's how I can actually attach to a debugger as well. So this is a great functionality which is in preview from a developer perspective. Now, the last thing that I would like to quickly show you and talk about, which I feel is a very important topic for anyone looking to deploy models using the Azure ML service, is the debugging of scoring script. Because scoring script, I mean, if you are familiar with Flask, is nothing but your main.py in Flask, which is used to take input request, process against a model, and then give out the outputs. So similar to that, even Azure ML's HTTP inference server is built on top of Flask to abstract some of the functionalities of Azure Machine Learning services, and debugging the scoring script is always a time taking process. And we do have some new functionality now where instead of debugging the scoring script in the Azure ML environment, which kind of triggers a build of your container every time, and you have to wait for the endpoint to be deployed and then throw out an error. What you can actually do is you can actually debug your scoring script locally on your machine first to make sure you have everything in place in the scoring script. Because typically a scoring script structure, let me just open one of the files here. So again, this is from the same samples. And if I just open up a scoring.py file.
Just one in 1 minute, you have to wrap up, Verma.
Sorry. So yeah, so usually,
I think at this
so
point,
this is the
we can go ahead, Verma.
yeah, let's wrap up then. Yeah, I'll share. I
Okay,
think Jamil is
sounds
going
good.
to share the links
Thank you so
anyways.
much for showing us these goodies, Verma. Really appreciate it. At this point, I just want to go towards the wrapping up. As I mentioned, summary-wise, we tried our best to walk you through the entire life cycle as a developer or a data scientist with Azure ML Studio as you're working with the machine learning models or solutions in general. Definitely encourage you to go through the collections that we have. All of the topics that we discussed today will be covered under the collection, so that will be good resource for us. Again, thank you everyone for taking the time to join with us, learn with us today. Thank you, Varma,
Thank
Todd,
you.
Jamil, everyone for helping us with the session today. And there are sessions upcoming. Feel definitely would welcome you to join the sessions and learn with us. Thank you everyone for joining. You all have a
Thank
nice day.
you. Thank you. Thanks everyone.
Thank you.